Hello, welcome to the first video on my channel. I hope to be starting a math problem compilation for solving problems on my channel. Hopefully you can participate too. I plan to be putting all sorts of types of challenges on the channel and just have a good time posting these videos. Anyways, the problems we're going to be dealing with on this channel usually are from different math competitions, such as AMC or AHSME or other sorts of math competitions. And usually they're going to be a bit interesting or do solving these problems in a bit of a different way that we usually don't see in a traditional solution. So today, as a first video, we're just going to warm up with the question that's asking us to compute the cosine of 36 degrees minus the cosine of 72 degrees. So how would we tackle this? Well, after playing around a bit, it's interesting to note that 72 degrees is exactly twice of 36 degrees. So we might need to know that. And also, maybe a bit less obvious, is the cosine of 72 degrees is just sine of 18 degrees, and 18 degrees is half of 36 degrees. While these may be pretty random facts that I might be bringing up, they're actually going to be very useful in solving this problem. So, by no means am I saying that this solution is the most efficient and effective way of solving this in a timed condition, but it is very interesting, I have to say. So, first off, let's do something not necessarily immediately very obvious, but we're going to express cosine of 72 degrees in two different ways. And with these two different ways we express cosine of 72 degrees, we're going to be able to figure out this number here that we get when subtracting this from that. So cosine of 72 degrees is just sine of 90 degrees minus 72 degrees, which is just sine of 18 degrees. Because we can say that cosine of a degrees is just sine of 90 degrees minus a degrees. Because this is just one of the basic trigonometric identities that are expected to be memorized, and hopefully you fully understand what they mean. So we have sine of 18 degrees is equal to cosine of 72 degrees. Now, we can use half angle formula to find sine of 18 degrees in terms of cosine of 36 degrees, right over here, because we find that sine of a over 2 degrees is just equal to the square root of 1 minus cosine of a degrees all over 2. Again, this is a very common trigonometric identity that's kind of expected knowledge, so these are all fair game when we tackle these problems. So we find in this first set over here that cosine of 72 degrees is just the square root of 1 minus x over 2. And by the way, I'm letting x equal to just cosine of 36 degrees, as I have up here. I just want to clarify that in advance. It's going to make things a lot easier to read later on as we delve into this problem more deeply. Also, another thing to clarify here is when we apply the half angle formula, we take the positive square root, because the sine of 18 degrees is positive. Why? Because 18 degrees is between 0 degrees and 180 degrees. And you can visualize this on the unit circle because it's in the top half. So it's in quadrant 1. And sine is positive in quadrant 1. So now that we have that, we just need another way of expressing cosine of 72 degrees. So, tackling it from another perspective, we have cosine of 72 degrees with double angle formula is just 2 cosine squared of 36 degrees minus 1. And this is a formula right over here, generalized for a degrees. And this is just the same thing because we let x equal to cosine of 36 degrees. It's just 2x squared minus 1. So now that we have that, this is just cosine of 72 degrees, and this is also just cosine of 72 degrees. So we can just simply set those two together and solve for x to find cosine of 36 degrees. And let's do that right now, and that will actually enable us to find this expression we have above that it's asking us to find. So setting those two together, 2x squared minus 1 is just square root of 1 minus x over 2. Squaring both sides, we have this, getting rid of the square root, and then expanding this expression, we have 4x to the fourth minus 4x squared plus 1 is equal to 1/2 minus 1/2 x. I just split this fraction into two separate fractions. Moving on here, we want to clear the denominators on the right-hand side of this equation. So we have 8x to the fourth minus 8x squared plus x plus 1 is equal to 0. Just rearranging terms here. And by inspection, you might think it's suspiciously interesting that we have two 8's here and a 1 and a 1 there. We can just plug in -1 to find that these two terms cancel, because they're both raised to even powers, and then -1 plus 1 is just 0. And we find -1 is a solution by inspection. So now what we do to find the rest of the solutions is we synthetically divide into this polynomial right over here, the -1. And we find, based on these set of row numbers over here, we bring down the 8, multiply, we get -8. 0 minus 8 is -8, multiply, +8. -8 plus 8 is 0, multiply 0. 1 plus 0 is 1, multiply -1, and then we get a 0. So this tells us that this polynomial can be factored as x plus 1 times, converting this over here into a polynomial, 8x cubed minus 8x squared plus 1. So by the rational root theorem, we can also find x to be 1/2. So rational root theorem, we just find all factors of the constant term and all factors of the coefficients of the leading term. And we plug each one of those numbers into the expression and see whether it equates to 0. And again, we can also find this by inspection. X is 1/2. That's another solution to this polynomial. So now again, to find the rest of the solutions, we synthetically divide again, bring down the 8 to multiply through again, and then we find this is just equal to x plus 1 times x minus 1/2 times, and then based on the set of numbers we have below, 8x squared minus 4x minus 2. And we still want to find when this is 0. Now we can factor out a 2 from this set of parentheses and put it into this set of parentheses to get 2x minus 1 times x plus 1 times this expression is just 0. Now we can just simply apply the quadratic formula to this expression to solve for x. And we find x is just equal to, simplifying over here, 1 plus or minus square root of 5 over 4. Now, here's our full set of solutions. We can't forget what x is. Remember, as we detailed before, x is just equal to the cosine of 36 degrees. So we need to find which value over here is the valid value of x. So first of all, we obviously know that cosine of 36 degrees is not -1. Cosine of 36 degrees is not 1/2. And cosine of 36 degrees is positive because 36 degrees lies in quadrant 1. So therefore, the only remaining solution that can be x is 1 plus square root of 5 over 4. So now we're really actually just almost there. We just need to plug back into this expression right over here. So cosine of 36 degrees minus cosine of 72 degrees is just 1 plus square root of 5 over 4. Remember, cosine of 72 degrees from before, cosine of 72 degrees is just equal to 2x squared minus 1. So we subtract 2x squared minus 1, and x is 1 plus square root of 5 over 4. Simplifying this expression down, we have this, getting common denominators, canceling terms, and finally, we have our final solution. It's just 4/8 or 1/2. Now, That may not be a very obvious course to find the solution to this problem, but it's still nonetheless very interesting. And I hope you enjoyed this video, and I hope you find my other videos interesting as well. Thank you. Bye-bye.